So I would like to welcome all of you to AI session today. So we are going to be focusing on credit risk analysis. I will be doing the presentation as usual. And then towards the end of the session, we will have Q&A. So if you can please mute your microphones right now so that we can go ahead and get started. So if you have questions, what I would recommend, either you write them down or you can send them to the text box, or you can just wait until the end of the session and then we'll be able to discuss your particular questions. So I felt that it would be important to cover today a module which covers essentially how you can use Python to manage like financial risks. And today we're going to look at a data set from a bank. Actually, it's a real bank, an online bank. So I'm going to go ahead and show you the data set right there. So that's the data set basically about different loans that this bank has given in the past, and it contains some features about the people who got the loans, which we'll be able to cover in details as we go through the presentation. So let's go ahead and then see what this is all about. So I'm going to go ahead right now and load the data set so we can have a look at it. So I'm gonna call this loans equals PD read CSV. The data set is located in the data set folder, loans data, yeah? Okay, great. All right, so let's have a look at this, loans.head. Okay, one of the things that we do in data science is to take a moment to actually examine the data that we are looking at. And we also need to know what is the problem we are trying to solve in this case. Imagine a situation where we have just been recruited in a bank. This bank wants to use the new AI tools to be able to do risk management. They have basically put together a data set. We will see how many records we have. Actually, we can do that right away. I can do loans.info to see how many records we have. Okay, so we have 9,578. So it's not a huge data set, but it's a good starting point. So what we are going to do here is to build a model that will help us predict whether somebody is going to pay back a loan. So the bank obviously makes money by issuing loans, and they want to ensure that whenever they make a decision to give to somebody a loan, that they have a higher probability of getting back the capital or the principal and some form of profit in terms of interest. I will go ahead and try to describe these columns. I thought that it's important to do that, because, you know, as we are trying to understand the data set, it's important to know what this data set is all about. Let's go through each column here. Credit policy. Basically, one denotes if the customer meets the credit underwriting criteria for this lendingclub.com. That's the bank, the online bank, which offers the loans, and 0 otherwise. So one means that they meet all the criteria to be given a loan, and 0 not. Okay, so the purpose is like the purpose of the loan. So here you have different reasons why people take loans. Some people take loans to pay credit card debt. Some people take loans for debt consolidation, which means essentially taking a loan to pay other loans. Not a good way to live, but you know, some people do it. Here we have the interest rate that's the bank charges that particular customer. The installment is what are the monthly installments that they have to pay. And then this is the log of their annual income. So this is the natural logarithm of their annual income. So, you know, you can look at this value and probably it would be like $80,000 if you convert it to the real value, okay? So it's just because we don't want a huge value here. That's why we use the log of that, the natural log. So, so the DTI, this is the debt to income. You know, in other words, what's the ratio with respect to the total debt of this particular individual compared to their annual income. And then here the FICO score, that's the credit rating of the customer. And here days with credit line, it's the number of days that the customer has actually an active credit line. The revolving balance, I believe I have a definition here. It's the borrower's revolving balance, which is the amount unpaid at the end of the credit card billing cycle. Revolving util, that's the borrower's revolving line utilization rate. In other words, the amount of credit card line used relative to the total credit available. In other words, if they have a credit line, how much of their credit line are they using? What's the percentage of that? This one here, it's the borrower's number of inquiries by creditors in the last 6 months. Notice they keep information about that. And then the other one here is delinquent within 2 years. This is the number of times the borrower has been over 30 days past due on a payment in the last 2 years. The one before last, which is public record, is the borrower's number of derogatory public records. In other words, if they have a bankruptcy filing, some tax issues, or some kind of judgments. Finally, here we have the column which is not fully paid. So not fully paid, that denotes whether the customer paid the loan or not. So when you look at this data set, if we are going to build a model, then the first question that comes to our mind is, okay, great. What is it that we need to predict? Well, from the bank point of view, they don't want to predict the credit policy. That's their decision whether they are going to give a loan or not. Now, the question is, once they decide to give a loan, which is one, in this case, they've decided to give a loan, what the bank doesn't know is whether they will be able to get the loan paid back or not. And that's why you see here this last column, which denotes whether the loan has been paid. Now, this can be a little bit confusing because it says not fully paid equal 0. That actually means that they paid the loan. So not fully paid equal to 0 it means that the customer has paid the loan. If it equals to 1, which is true, not fully paid equals to 1, which means they have not paid the loan. Okay, so that hopefully provides us with some information about the data set. And now what I'll do is I'll go ahead and start the process of trying to get some insight from this data. We already had an idea about, the first few records in the data set. You can obviously look at the last records, loans.tail. We want to look at the tail right now, which is the end of the data set, like that. One of the things that we might be interested in is, for instance, we might want to start asking some questions like, well, what we want to know, what's the average interest rate that the bank charges for these loans? If you remember, what we can do, loans.describe, right? So if I do loans.describe, that will actually provide us with a nice statistical summary, which basically tells us like that the average interest rate, as you can see here, is about 12.26%. Yeah, and then the average monthly installment, notice, is $319. Yeah, okay, and then that's also the average credit rating or the FICO score, and then you can look at other values. And if you really are only interested in, like, let's say, the interest rate and the FICO score, you can actually select those two columns, right? So you can pick the interest rates. And then we want to pick the other column if we are also interested in the FICO score. That one I can just, so in this case, you get to look at these two parameters. As I was looking at the data set, I don't know about you, but when I look at these values in terms of the log.annual income, I like to see some kind of absolute value here. And, so I was just playing with this and trying to see how we can actually convert that. There are ways that you can do it. There are different ways. Here is one way. If you really want to convert it to the actual real value, I'm going to use, we have already imported NumPy, excuse me. So I'm going to say annual income equals loans, and this is going to be log.annual income. And that's the column name. And then I'm going to convert this to a NumPy. So that it will be a NumPy array. So it looks like it worked. Okay, fine. So you can just double check if this is actually a NumPy array. So When I do this, notice, yes, it is a NumPy array. Since this is the log, the natural log, so to get the actual value, I need to use the exponential, right, to get the annual income. So I'm gonna say the actual annual income. I know it's a long variable, but this is just to help us explain this. So I'm gonna do, it's the exponential of the annual income. And notice this is gonna calculate this for the whole column. You can actually look at the first 10 salaries, and then you can start looking at the salaries right there. So you can see that, you know, for instance, this one here, it corresponds to 85,000 US dollars. Or you can calculate the mean if you want to just have what's the average annual income in absolute values. You can just calculate the mean. So I'm going to do actual annual income dot mean, and then it will provide you the average income on this data set is about $68,000. All right. So that's something to keep in mind. Now what we are going to do right now is we are going to do some data visualization to get an idea about what this data set is all about. So what I'll do is I'm going to go ahead and then print the columns that we have in this data set. So these are all the columns that we have. For data visualization, I'm just going to try to see if there are some correlations or some relationship between the features that we have in this data set. So what I'm going to do is create another data frame. I'm going to call it loans subset. This will contain a subset of these columns. So I'm going to copy all of these, and I'm going to remove the ones that we're not interested in. So the ones that are like Boolean values, they are not really helpful. So I'm going to remove that. Also purpose, that's like, it's a categorical data. So I'm going to remove that also. The interest rate, it's okay, it can stay. The installment is okay. Log of the annual income, it's okay. Debt to income ratio, that's fine. The FICO score is okay. Days with credit line, revolving balance is okay. And then revolving balance.util. And these other ones, it's just, these are Boolean values. I'm going to go ahead and get rid of them. What I'll do right now is do what we call a pair plot. You remember we've saw that. So this is a time to practice some data visualization. So I'm going to do fig size. It's going to be 12,8. And then what we are going to do now is going to use a SNS pair plot to see if we can see some patterns in this data set. This should be loans. I'm selecting from loans. So now I'm going to have a look at my loan subset to check if this is a data frame. Okay, now it's a data frame, then this should work then. Yeah, okay. So it will take a few seconds to run. We'll give it as much time as it needs. So basically, we're trying to see if there are any correlations between the features. So when you look at this, you can go through this and try to understand if there is some kind of correlation between the features. Well, you know, right away, you can see that there are some interesting things. Like here, notice this is the FICO score right here. There is an inverse relationship between the FICO score right here and the interest rate. So in other words, if somebody's credit rating is really good or high, they tend to pay less interest rate, which makes sense, right? Customers with good credit rating, they can really negotiate. They can go to several banks and try to get the lowest interest rate possible. So that's why we see this inverse relationship. So that's one relationship we can see. There might be some other relationships. Yeah, but this is one way to quickly identify if there is a trend. So that's one way to do it. If you remember, there is another way we can do this by using a heat map, right? So what I will do right now is try to use a heat map. I'm going to go ahead and copy this line to make sure we have nice and big figure. I'm going to do SNS heat map, and I'm going to say loans.core, in other words, the correlation. I'm looking for correlations between the variables. Annotation equals true. In other words, I want to see the values. And then let's say heat map equal vary this. This is just a coloring scheme. So when you look at this, something that could jump right away is that, notice, the darker the value, closer to purple, when the color is close to purple, that means that we have a high correlation, or this is an inverse correlation, by the way. So you can see again the relationship between the FICO and interest rate. It's pretty strong, you know. It's an inverse relationship, but it's pretty strong. It's about 70% or 71%. There are some other relationship, like notice there is the revolving that util right here with the FICO score. You remember maybe in your stats course, correlation is a value between usually 1 and -1. When the value is like positive and it's close to 1, that means that there is a strong positive relationship. When the value is negative and it's close to -1, that there is a strong inverse relationship. And that's what we have here. Since we have identified that there is a strong relationship between the FICO and interest rate, we may want to investigate that relationship a little bit further. So what I'm going to do right now is to, let me go ahead and then do that. And then I'm going to use a SNS joint plot. So I'm going to say joint plot, and then X, it will be the FICO, and then Y would be equal the interest rate, right? And the data frame is loans. And then let's say the color that we want to use now is purple, okay? So when you look at this, now you can see that again, that relationship is really pronounced right here. And actually we can even model it with a linear regression model if we wish to. So that's what I'm going to do right now. I'm going to use a linear model, a model to approximate this relationship, and SNS can help us to do that. If you want to do a linear model, you can do LM plot, and then again, X equals the FICO score, and then Y equals the interest rate, and the data equals loans. And now I'm going to add a hue to help us identify people who paid versus people who didn't pay, right? Because that's one of the things that we are interested in, fully paid. Yeah, so you can see here the relationship. Again, the red, which is 0, not fully paid, notice this is negative, equals false. That means that they have paid. I know it's a little bit confusing, but here the red denotes the people who have paid, and then 1 are the people who didn't pay. Notice something rather interesting. You can see there is lots of people who actually have paid. They tend to have, you know, a high FICO score. So, and then their interest rate obviously is low. That's what we can say about it. I know Saeed has asked me how you can select particular rows in the data set before. And what I want to do right now is just show you, like, let's say I want to create a data frame which contains people who have not paid, right? I want to select a data frame which contains only people who didn't pay. So I'm going to say not paid loans. So I'm going to say this equals loans. And then here we are going to have a Boolean expression. So notice I'm going to use again the data frame loans, and I'm going to say not fully paid. And this is going to be equal to 1. So these are the people who didn't pay. Okay. You can actually look at the data set if you want. You can do not paid loans, I'm sorry. So these are the people, again, who did not pay. You can try to analyze this. But let's say we just want to count how many people didn't pay. So if I just do count like that, notice that it will show me the count of lots of each column. But I'm only interested really in one value. So what I can do, I can just do 0, and it will give me the values. In this data set, we have 1,533 applicants or loans, people who got loans and they didn't pay. All right. Now, on the other hand, if you want to look at people who actually paid, we'll use similar procedure. So not only Now we are going to change this to paid loans, and this will equal 0. And then you can take this also. And then notice now that we have about 8,045 loans that have been paid, okay? What you may want to do is to try to visualize the distribution of the people who paid versus the people who didn't pay using a histogram. And that's possible that we can do. And for that, I'm just going to use this. So let's go ahead and see how we can represent this with a histogram. So we are going to start with the not paid loans, right? And then we are going to select from that data frame. We're interested in the FICO score, which is the credit rating. And then we are going to look at the histogram. In other words, we're trying to see, are people with high FICO scores, do they tend to pay the loan? We want to look at the distribution. Or these are the people actually who didn't pay. So if this is a histogram, then I'm going to specify the number of bins, which is 30. Alpha is the actual opacity factor. I'm going to show you that in a moment. And then let's say color equals blue, and label equals not paid loans. Okay, so that's one diagram that we can put there. And let me go ahead and also say plt.legend. And I'm going to also do plt.x label equals is going to be the FICO score. Okay. You know, this is a histogram, which maybe this is a little bit big. Let me change this to 10. And then this is maybe to 7 or 6. Yeah. So this is a histogram that shows us the distribution of the people who didn't pay the loan in terms of their FICO score. Yeah, you can see that people with low FICO score, they tend actually not to pay the loans. You can compare that with the people who actually have paid. So let's try to do that right there. And instead of blue, this is going to be red. And let's change this to paid loans. So what you can see here, the blue are the people who didn't pay. So although it looks like a purple, but actually here at the bottom right here, that's blue. And then this color here, like pinkish color, that these are people who have actually paid the loans. So you can just have a visualization in terms of, you know, people who paid versus people who didn't pay with respect to the FICO score. If you notice, we have a categorical column in the data set, which basically describes the purpose of the loan. So if I do loans.heads, notice that we have this particular column right here, which is categorical. And you may be interested to know, like in this data set, most of the people take loans for what purpose? You might ask this question. Maybe the bank is going to concentrate on that particular segment, you know, of their customers. So let's see if visualization can help us to do that. And I'm going to go ahead and do SNS.count plot, and then X would be equals the purpose of the loan, which is, as we said, it's a categorical value. And then the hue would be equals, we are basically separating the people who paid versus people who didn't pay, not fully paid. And then the data equals loans, and then palettes equals set 1. So let's see what we'll get right here. This red, although you might interpret this as people who didn't pay, but actually the red denotes people who paid, you know, not fully paid. Again, equals false, that means that they have paid. And then the blue are the people who didn't pay. So notice for this particular online bank, most of the loan applications or most of the loans that they are processing are for debt consolidation. So what is that consolidation? Well, I'm not a banker, but from my general understanding, that consolidation is this idea that you take a loan to pay other loans. Instead of having maybe 5 or 6 different loans, you put all of them in one single basket, or you refinance them, or they call it refinancing, where you pay off all those loans and then you only have one loan to pay. So that seems to be like most of the customers for this bank, they take loans for that consolidation. Some customers, they take also loans to pay credit card bills and so on. Basically, these are US customers. Notice here we have no idea about the amount or the dollar value of the loans. This is just a count of the applications. So maybe the bank manager will look at this and say, man, most of our energy and effort goes into processing that consolidation loans. So they'd better be profitable, because lots of work here. This requires lots of work to process all these applications. So they might have some insight right there. Okay, now what we will do is we are going to just proceed right now with the machine learning part. And I want to alert you to the fact that today I'm going to show you just really a basic model. So this is not going to be a model that's going to be performing very well, but we are going to use it as a starting point. Maybe in the future, we can look at how we can look at other models, or maybe how we can tune the model, right? And we're going to use, in this case, logistic regression. One of the things that we need to do for the data set is to actually transform this categorical column right here, the purpose, into numerical values. So let's go ahead and do that. Categorical features. So we only really have one, which is the purpose, and we want to transform it to a numerical one. Why? Because our model does not understand categorical data. So what we will do is we're going to say final data equals pd dot get dummies, and then here I'm going to say loans columns equals categorical features. So in other words, we are going to convert this as you will see, Boolean values. Drop first equals true. So now if I do final data dot head, so notice that the purpose column is gone, and what we have instead are columns for each individual category. So you can see here purpose, that consolidation. So if it's true, you will get 1. If it's false, you will get 0. And then here you have other columns for other categories. This is something that we need to do if we are going to use models that cannot really understand categorical data. So we need to do this transformation. So let's go ahead right now and try to build a model. So I'm going to say from sklearn dot model selection. So we want to split the data, import train test split, and then x equals final data. So it's going to be the final data. And then we want to remove the target column, which is not fully paid. That's what we're trying to predict, right? And then the axis equals 1. That's important. And then y would be the column that we are going to predict. It's going to be final data and then not fully paid. All right, and then what we are going to do right now is to go ahead and split the data into train and test, as you saw in the videos, in the previous videos in the course. So I'm going to go ahead and select this. That's going to help us do a random split of the data. And so let's make sure that the test size is 30%. The random state, let's make it 101. That's just like a value that we use to make sure that you and I have the same random split. And then what we are going to do is we are going to use a logistic regression model initially. This is the first model that we are going to consider. So I'm going to say from sklearn dot linear model import logistic. So we want to import logistic regression. And then we want to go ahead and then initialize this model. So I'm going to call this LR model equals logistic regression. Let's go ahead and train the model. Sorry, we will fit it, and then we will give it X train and then Y train. I will increase the number of iterations to get rid of this. So I'm going to say here max iteration equals 500. Okay, so now we have trained our model. So let's go ahead and do some predictions. Predictions equals our model that predicts, and then we will give it a new data set that the model has not seen, which is the X test, right? And then what we will do right now is to try to evaluate the model. And if you remember, a couple of techniques that we use for evaluation, model evaluation, is we use the classification report, which will print the precision, the recall, and the F1 score. I believe I described them in the previous videos, but we can go over them quickly if you would like. So to do the model evaluation, we are going to say from sklearn.metrics import classification. So yeah, we want to import classification report, and let's go ahead and also import the confusion matrix. Now I'm going to say print classification report, and we want to compare the y-test and the predictions. Okay. If we are just going to look at the precision here, for class 0, in other words, for the people who paid the loan, we are getting a precision of 85%. Whereas for people who didn't pay the loan, we are getting a precision of 60%. And then look at the recall. So for class 0, the people who paid, precision is like, the recall is 100%. And then the recall for the people who didn't pay the loan is not that great. It will be worthwhile to take a moment right now to just review what we said about what is the precision, what is the recall, and what's the F1 score. And what we are going to do right now is to just review this. So first, I would like to just talk about this idea of a confusion matrix, right? So I want to clarify that again. So as we are considering to evaluate the model, we have an idea. So here we are going to look at the actual class. And then here, so we will have a nice box right here. And then here we are going to have, this is P stands for positive, and then negative. And then what I will do here is, and have a nice line right here. This is the predicted class. And then here we will have positive and negative. Great. So what is this confusion matrix? Well, here essentially with respect to the data, because we know for the test data, we know what the actual answers are. So if the predicted answers are the same as the actual answers, we call that true positive, right? So here we have, for instance, these are the people who have paid the loan, true positive. In other words, somebody has paid the loan and we predicted that they have paid the loan. So that's true positive. This is negative. So in other words, the people who didn't pay the loan, and our prediction also that they didn't pay the loan. So this will be the true negative. So obviously we need to optimize this. So we need to get as many values in this part. Here we want to make sure that our predictions are correct. And in this case, our predictions here and here, they are correct. Now let's look at this case here. Here, the prediction is that we're saying, no, this is negative, but actually it's positive. That's why we call it false negative. Because we're saying, look, they're not going to pay the loan, but actually they are going to pay the loan, or they paid the loan. And here, this other case that we're looking at right here, we call it false positive. So in this case, notice we predicted, yeah, they are going to pay the loan, but the actual data tells us that they actually didn't pay the loan. So obviously, what we're trying to do is to maximize this particular area right here. Yeah. So in a nutshell, what is the precision, what is the recall, and what's the F1 score? the precision, if we want to follow the textbook definition, equals true positive divided by true positive plus false positive. So in other words, from the ones that we predicted to be positive, notice these are predicted positive. How many of them are actually positive? That's the precision. Whereas with the recall, it's actually, again, true positive, and then here, true positive plus false negative. So what is this? This is the actual positive. Okay? So in other words, the recall measures from the actual positive, how many did we get right? Then the F1 score is basically the harmonic mean, which is 1 over 1 over the recall plus 1 over the precision. So when we go back to our model, so the model seems to be doing well in terms of precision, but with the recall, it's not doing that well. And typically the value that we use for binary classification, which is the case that we are looking at today, we look at the F1 score. And again, if we go back to our notebook, yeah, so you can see in this binary classification model that I used, which is the logistic regression, the model for class 0. So what's class 0? Well, those are the people who actually paid the loan, people who paid the loan. So notice that the F1 score is good. So we were able to predict, really, we did well in terms of predicting people who will be able to pay back the loan. However, for people who didn't pay back the loan, the model is doing really poorly if we are going to look at the F1 score. So far, the work we did is a good work. It's not, it's a good analysis. But at the end of the day, the bank wants a model that they can use to automate this risk assessment or risk management and to be able to know very quickly or process the loan applications very quickly using a model. So what are the options that we could look at? And I will obviously open the discussion in a moment and we will have a discussion about it. But here are some ideas. One, first is to consider using another model. And for classification, but especially binary classification, there are other models that we could consider using. One of them is called decision trees or random forests that could be used. We could even use maybe neural networks. However, if you look at the size of the data set that we have is pretty small. So if we are going to use neural networks, then it's best to have a large data set. I don't know, something like probably at a minimum 100,000 loan applications. But these are some of the ideas to keep in mind. And then the third thing, you could actually use a model, but the default values of the model need to be tuned. And some of you who are going to be taking some of our advanced courses like deep learning, we are going to have the opportunity to discuss how you can actually tune a model. Yeah? Okay, great. So that's all I want to talk about tonight. What I will do right now is basically open the floor for questions. So let's go ahead and do that. Okay, any questions? I know, Saeed, you are in the finance field, so you must have plenty of questions.
Yeah, this is actually very clear. Thank you so much.
So, Saeed, is this similar to what you would normally face in your financial analysis, or?
Yes, yes.
Mm-hmm.
It's very important, especially for credit analysts.
Yeah, yeah.
They will do that for sure.
Mm-hmm. Mm-hmm.
They will do that. And I would say my question. So first question is regarding EXP. You used EXP.
Yes. Uh-huh.
At the beginning, I didn't get why.
Yeah, so like this, this annual income, Saeed, is expressed as the natural logarithm. Yeah? Do you remember the log function?
Yeah.
So it's like, it's expressed in terms of like the power, like 10 to power like 6 or 7. So this is expressed in terms of the power, if you can think about that.
Okay.
And
Yeah.
why
Yeah.
we do that? Because we don't want to display a humongous value here, you know? So you know, for me as a data scientist, I'm interested to know what's the actual income. And that's why I did the conversion.
Yeah. What is the conversion? Can we go back to it?
Yeah, sure. Yeah, so notice that what I did here is first I extracted this column. This is a pandas data frame. And then I obtained the annual income, right? So that's like the annual income, and this is going to be now in NumPy. So let me go ahead and show you what that initially. So annual income, and if you look at the first like 10 values, notice they are expressed in like the powers. Just think about this as the power, right? And then what I
Yeah.
did here is used exponential, the exponential, and I gave it the values, and then it calculated the income for all the values.
Okay.
Yeah. Okay.
Yeah. Another question. So,
Yes. Yeah. Go
let's
ahead.
say that the model was not satisfactory,
Yes, which is
and
the case in our, which is the case that we have right now. Yes.
yeah. So, what would be the next options? Is
Yeah.
it going
Yeah.
to be automatically to try another statistical method like other regressions or
Yeah.
other
Yeah.
models, or would it be to look for other data that can better explain? Yeah.
So good question, Said. A very good one. Let's imagine that you really don't have the option of getting more data. So really the only thing you can play with is to experiment with different models. And for binary classification, this is probably the least performing one, is the logistic regression. So what people normally would use in situations like this, they would use something like random forests, which basically based on decision trees. In a decision
Yeah.
tree situation, you start with the root. Like for instance, you ask a question: is this person employed or not, or is their FICO score less than a certain value? Automatically, if it's less than a certain value, their loan application is rejected. And then you start continuing your analysis. One thing also that can be done is not just selecting the model, but also tuning the model. For instance, when you select random forests, there are lots of parameters that you could use to tune the model. And for that to be done successfully, you need to be familiar about some mathematical background behind how the model works. So that's
Yeah.
one.
So,
So that's
yeah.
one option. Then the second option is obviously if you can get more data, you can even consider using neural networks.
Excuse me, see Ahmed, quickly
Yeah.
before you do this random forest about the F1 score. We have for one, which means unpaid, we have 4%, right? And
Yeah.
this is the reason why it's not satisfactory for the bank. This is why
Yeah.
our model
Yeah.
is not good, because they want to
Yeah.
predict the clients that will not pay, not those that are paying.
Both,
Yeah, but
yeah.
they are more interested since they want to reduce the risk,
Yes.
to get a real value, a very close value for those who will not pay.
Yes, absolutely. Absolutely.
Okay. Okay,
Yes.
thank you.
And that's the problem here. Yeah, exactly. So, the model is doing really poorly right there. So,
Okay.
yeah. Are there any other questions before we close the session? All right. Well, that's all I want to talk about. Thank you so much for coming today, and I will see you next time.